So for this video, we're going to work with complex numbers and kind of treat them like variables so that way you can be more comfortable with them. So for instance, I have 7 minus 5i times negative 8 plus 2i. When you're multiplying two complex numbers, you want to treat it like you're multiplying two binomials. So you have two terms. Therefore, I can apply FOIL. I write out FOIL. F-O-I-L. My first term is 7 times negative 8, which is negative 56. My outer terms are 7 times 2i, which that equals 14i. My inner terms are negative 5i times negative 8, which that becomes positive 40i. And my last term would be negative 5i and 2i. And that becomes negative 10i squared. The only thing that I need to focus on first before I combine my terms is working with this I square idea here. I can replace I square with negative 1, and negative 10 times negative 1 becomes positive 10. Now I can combine all my like terms. So negative 56 and 10, when I add them together, becomes negative 46. And when I add my other two, 14i and 40i, that becomes 54i. And I'm done. For the next problem, we're working when we have our I values higher. So for instance, negative 3 plus 7i to the third minus 3 minus 4i to the fourth minus 8i 10 to the 10th. Oops. Let me write it. Okay, so there's two approaches. You can either apply your PEMDAS, orders of operations, or deal with the I. I personally like to replace every I that does not have that has a power. So for instance, I to the third, I to the fourth, and I to the 10th. Now I to the third, so I rewrite what it's not going to change. Negative 3 plus 7 times, this becomes negative I. You want to think about the complex plane. If you start at I0, at here, we have I squared, and I to the third, which is negative I. Rewrite what's still not changing, so minus parentheses 3 minus 4. Remember, we like to work with the 4s because that equals 1. And then another parentheses minus 8i to the 10th. Now I to the 10th is a little bit tricky. So I to the 10th, here's my side note. I to the 10th, we start thinking about I to the 4th. How many times does 4 go into 10? So it goes in twice with the remainder of 2. So I can rewrite this I to the 4th 2 times with the remainder of 2, my exponent. Remember, we like working with I to the 4th because that equals 1. And I can cancel that out. So this becomes 1 squared times I squared. And 1 squared equals 1. I squared is negative 1. So I to the 10 equals negative 1. And I replace that. Let me erase this here so that way I can clear up the work. Now I apply orders of operations. Orders of operations state parentheses first. So negative 3 plus, here's my first parentheses, negative 7i. My second one, I need to distribute the negative. Negative 3 plus, and then here's an inner parentheses, 4 times 1, which is 4, plus 4, my second parentheses, negative 8, times negative 1 becomes positive 8. And I start combining all like terms. So I start off with my real part, negative 3 minus 3 is negative 6. Negative 6 plus 4 is negative 2, and negative 2 plus 8 is positive 6. With the complex part, the imaginary part, there's no other term, so it's, here's your final answer, 6 minus 7i. Last one, this one's a little bit lengthy, would be the complex polynomial 3x to the third plus 2x plus 15i x to the third minus 6 minus 3i minus 5i x to the third plus x plus 2i x plus 1. I like to first write this in order in standard form. So when we talk about standard form, we talk about the power x variable with whatever power is being raised to. I see that x to the third is the highest, so I start writing it down. 3x to the third plus 15i x to the third. Start calculating them out so I can clear up some of my work. Minus 5i x to the third. And that's it for the x to the thirds. Then I look at my x's. I have a plus 2x. I have a plus x. And I have a plus 2i x. And last but not least, my complex number. Plus negative 6 minus 3i plus 1. Okay, took care of all. Now I start by sectioning off and combining like terms. So I can combine some of my imaginary parts. 1 second. 3x to the third, 15i x to the third minus 5i x to the third becomes 10i x to the third. My x's, my real part, can be combined. So I have the following. Plus 3x plus 2i x. And last but not least, my complex number itself. Negative 6, negative 3i, and plus 1. Negative 6 and 1, the real part gets combined, and that becomes negative 5 minus 3i. So now you want to factor out your powers so we can have complex numbers. So x to the third gets factored out. Change the color. and you write your real part first, then your imaginary. 3 plus 10i. Complex number, 3 plus 10i times x to the third, plus 3 plus 2i times x, plus, in parentheses, negative 5 minus 3i. And we're done.